third down, I think you said. You got it. But the trick is being able to get it conveniently and comfortably when you need it. So let's talk about Michael Phelps, Mark Spitz. Now some of you are too young to remember Mark Spitz.
Yeah.
With a mustache like that, I don't know how you're going to forget it.
He's a swimmer.
He's a swimmer. He's a hell of a swimmer. 72 Olympics, which were in, oh God, I don't remember.
Didn't he crack his head?
It was in Munich.
That was Louganis. He was a diver, 10-meter board. Oof, man, that was.
It was in Munich.
Munich. Thank you. München.
Yeah. Well,
Ah.
there's a little bit more to it than that. Yeah.
Well, it's all So yes, Spitz, 7 gold medals in Munich in 1972. Phelps, 8 gold medals. 08 was
Beijing.
Beijing. Thank you. The cube, right? That was the swim. The cube. So the question I have is, who's more impressive? Who's more impressive, Spitz or Phelps?
What are you basing impressive on?
I'm going to let you base impressive. I have my own theories, but I'm going to have you guys base your impressive. I can say Spitz is more impressive because of that mustache.
Way up.
And that head, that is way hotter. There we go, way hotter. Good. Way hotter. I'm not going to disagree with you.
I would say
That hair.
Spitz.
Spitz, how come?
Because for just like once again spitballing, it's the how the training was back in 1972 compared to 2010 or whatever year that was. The equipment, the pool, the coaching, all that stuff.
40 years, right?
Right.
Well, 30, I guess. 30 years of change, 35 years of change between 72 and 2008. Phelps has advantages Spitz didn't even dream about in 72. So maybe the argument, this is good, the argument is more natural talent than technological advances.
Phelps benefited from the training and all the data and everything that came out of Spitz. Spitz was a phenom.
Oh, totally. But can we quantify that? Can we quantify that phenomenalness? So we have 2 votes for Spitz. One because he's hot, one because he's a phenom.
What was their age difference between when he was?
Oh, that's a damn good question. Does anybody know the answer? We can Google it.
Say again?
Was there an age difference? Spitz looks older, but it could be because of the stash.
Well, that picture could have been taken, way after the Olympics too. So.
It could have been. This was a Sports Illustrated cover. I don't remember what that was from. I know this was done as a reaction to that picture.
I would say that.
So.
I would say that Spitz would have been older.
Okay. I wonder if it was significant. And I wonder if swimming's one of those things where you tend to get maybe 5 years won't make a difference. Let's ignore the age thing because I didn't quantify that. We can obviously quantify it, but if you knew that, I'm not sure how we would use that to prove. If he's more. And again, the more impressive is slippery. I'm letting you guys pick what more impressive is. Well, he has 8, and he has 7, so therefore, boom, Phelps. Vote for Phelps. Vote for our big-footed friend, 6'9" Michael Phelps, whatever the hell he is. But that seems like as soon as I said that, people are shaking their head like, whatever, dude. Whatever. One of those was a relay medal, I'm sure. So whatever, blah, blah, blah. And it's actually interesting. They only shared 3 events they both gold medaled in. There are only 3 events they both got the same gold medals in. It was the 200 fly, the 100 fly, and I think the 100 free. I've got the data here. We'll share it in a second. Everything else was different. Like I think Phelps is a breaststroker, I think.
Yes.
I don't think Spitz was. Spitz was more of a backstroker freestyle, I think. I'm going by memory here. But they do have 3 events they have in common, which made me happy. Because they had 3 events they had in common, what can I do with those?
Check the times.
Ha! I can compare the events they have in common and see if there's differences there. See, that's when I get happy. Then I don't have to like 8 versus 7. It's like, yeah, but it's 2008 versus 1972. Like there's so many variables besides that. But if they're swimming the exact same strokes and winning the same, if they're the best in the world in the same stroke, that gives you something to work with. Then I've got like apples-ish. Well, ish, you'll see why. Here's some data for you. This is a 200-meter butterfly. I can't imagine doing more than 25 of a butterfly without my heart exploding. These guys do 8 of that, 8 times that. So here's Spitz, and this is the gold medal round in 72 and the gold medal round in 2008. Okay, gold medal 72, gold medal 08. I've got Spitz and all the dudes in his heat with their average time and their standard deviations of their times. And I've got Phelps and all the dudes in his heat with the average time and the standard deviation of their time.
That's pretty impressive.
It is. Tell me some first impressions of this data.
Looks like we're doing steroids or something. We kind of reduced that time by a lot.
But good. Looks like we're doing steroids or something. I like the or something on there, right? What are we doing between 72 and 08?
We're training.
We're training differently. We're wearing those crazy shark suits that are faster than skin. You know, we're just all kinds of. Have you seen them? If you look at the videos from '72 versus the videos now, these guys stay underwater doing dolphin for like half the length. I went to the Bend Rec, or not the Bend Rec, the Bend City swim meet. Watched Tommy Brewster swim. You guys might have read about him in the paper recently. Tommy Brewster, he's like this 1 in a million swimmer. He's incredible. We see him every morning.
He'll be an Olympian. There's no
He
doubt.
will be. He will be. Doing the 50-meter butterfly. He was underwater as long as he was legally allowed. He would stay underwater the entire time if he could. 3/4 of the length of the pool, underwater doing butterfly, doing dolphin kick. Because that's faster than being above the water doing butterfly.
And it's,
They didn't do that back then.
and it's
They-
less taxing on your body.
It is less, so you save your energy.
Yeah.
They didn't do it in '72. Marnie!
Well, weren't you only allowed 4 kicks underwater? I used to swim. and
Oh, maybe they changed the
there was
rules.
only- I think you were only allowed.
Change the rules. So that could take some time off right there, Veronica.
Yeah.
Boom. So obviously, this is not apples, apples, is it? This is not apples, apples.
It's not really that big of a difference. I mean,
It isn't.
Well, hang on now. Hang on now. Look at Spitz's time in '72. That's the gold medal world champion winning time in '72. Look at the last place dude in 2008.
He would have smoked him.
The guy in 2008 who came in last, who essentially you didn't even see him because the cameras were already focused on Phelps, was 100th faster than Spitz in '72. So I do agree with you that by seconds or hundredths of a second, there's not a huge budget difference. It's 100th of a second. But that makes all the difference in these races. If this were a 1,000 or a 2,000 or a 10,000 meter race, we wouldn't be talking in terms of hundreds of a second. We're talking about minutes, or in my case, hours. These 200, these are like Evinrudes in the pool. Watching these guys and these girls swim these races is like watching Evinrudes. Steam coming off the water, it's crazy. So we have to figure out a way to quantify the difference between Phelps and Spitz. Because there's some things in the air that are hard to compare, like all of these are lower than all of these. Did you notice this
Yes. I did.
versus that? This is photo finish essentially, unless you can see 100th of a second, which I know I can. This, 300ths of a second, that's actually almost visual. I mean, if you watch the '72 final in this meet, it's like, oh, there's Spitz and everybody else. And so phenom, again, phenom. So it's if I wanted to measure the difference between these two guys, it's getting harder now that I have data, right? It's harder because I've got averages, I've got standard deviations. But how do I put it all together? Die, go.
If it's down to 100th of a second, wouldn't just the fact that Michael Phelps' arms were longer because he could touch the end of the pool before, so
Oh,
they
genetic
shorter
freak.
arms?
How tall is
Spitz had
Spitz?
extremely long.
He's not very tall, actually.
He's not very tall.
No, he's not.
So that's a genetic disadvantage,
But
whereas an
whoever can
advantage for
reach
Phelps.
furthest.
Well, plus his feet are like this big. Phelps' feet are like my feet with flippers, which is amazing. Put flippers on, I'm like, dude, I have my.
It's like size 18.
I take them off, I'm like, nope, still not.
Size 18.
Size 18, which is terrifying. Good, okay. But the thing is, if I put up the 2008 times for the women, they're still going to be equally impressive against 72. There are differences, obviously, between these two data sets, but they're also measuring the same thing. So I think there's a way to do it. We have to do a conversion, yes? Essentially, these two live on two different bell curves, if you will. One has an average here, one has an average here. They both have a similar standard deviation. What I want to do is get them both onto the same bell curve. Yes,
I have a question.
please.
You know, you said there was 3 events.
That they all shared in common.
Do you have all that data?
I do, and we'll get to it in a minute. Rather than doing all 3 at a time, we'll do one and then go back and look at the other 2. I've got the 200 fly, the 100 fly, and
I wonder if the averages and the standard deviations are relatively the same
you'll have
in
it in
the
a
other 2
minute.
data sets.
You'll have it in a minute. Not in a minute. Yeah, I promise. But first, let's convert. If that's okay. Jolene, go ahead.
So could we set up a ratio of
Yes.
averages?
Yes, this is what we do. What you do is, you find the z-score. You need the z-score, which is putting it onto that curve that you have. You need to take your raw data, which lives, if you will, on this curve, the IQ curve, for lack of a better term. It's some other curve, and you need to convert it down. Remember how I was asking you guys? I'm going to pause this for just a second. Remember how I was asking you guys, where does this 90 live? Where does this 90 live? And you went, oh, it's like 2/3 of the way down from 100. Well, the reason you said 2/3 is you said, okay, 90 is 10 points down. That's 10. But standard deviation is 15. So in your head, you're going 10 divided by 15 to get 2/3. You didn't realize you were doing that, but that's exactly what you were doing. And then this guy here, 80, is 20 down from 100. 20 divided by that 15 of standard deviation gives you 1 1/3, that Pat had said. So you get, that's pretty much just simple universal truth. You figure the absolute difference, and this is where 244 lives in this calculation right here. You take Mark Spitz's time that he had in 72, figure out its difference from the average time in 1972, which was 2.066, divide it by the standard deviation of those times, and he gets a z-score of negative 2.01. Negative 2.01. Why is it negative? Why is it negative? Because he's the fastest one, which means his time is below average. If you're below average, your z-scores are going to be negative. If you're above average, it'll be positive. We'll see both of those today as we work through, so I got a bunch of examples. So that means that Spitz is 2 standard deviations below average. That's when we start going, oh, wow, that's cool, right? That's when we start saying something interesting just happened, right? Now we can check to see how Phelps did compared to average, right? So the same exact calculation. Take your 1.867, which was his time in 2008, take off the average of his heats. Notice that's not the hugest difference compared to Phelps, right? That's not the hugest difference compared to Phelps, because those dudes in 08, if you think of it as an echelon in the pool, 72 look more like this, whereas 2008 look more like this, because they all have these crazy scientific training principles. Divided by the standard deviation for that year. Now Phelps is still negative, and hopefully he has to be negative, right? Hopefully that makes sense. Why does he have to be negative? Because he won the gold medal, which means he has to be below average. I mean, you can't be the first one with the best time and be above average. That just wouldn't happen mathematically. So he's negative 1.62, so he's about 1.5 standard deviations down. I'm not about to critique that, because that's freaking ridiculous. I don't think I can do 25 at a time looking to do 200. But is he as impressive standard deviation-wise as Spitz?
No.
No, Spitz is more extremely low. He's an extra half a standard deviation down. So this is my vote. My vote is in the 200-meter fly. Spitz is more impressive than Phelps based on time. Based only on time, that's my only argument. Not his hotness, based on that.
But you're like, but it's based on his competition.
How else am I going to compare it? I mean, I need to compare his time to something else. I see what you're saying, Pat. I see what you're saying, but I have to compare it to something. I can't just compare his time to Spitz inadvertently, just those two pieces. And I thought about including more data in rather than just the gold medal heat. But then you're going to have this crazy wide standard deviation because you're going to get all like the Jamaican bobsled team swimmers that are going to take forever, like me in the pool, basically. Does that make sense? So this was just, that's why I said this is my vote. This is not the all of this is my vote for impressive as Pat.
Because, yeah, and I appreciate that, but if you look at the competition in 72, those guys in the gold medal round were relatively training in the same styles, and you know, there was some slight differences, as well as the guys that were swimming in 2008, their training programs were relatively the same. That's why those times are so significantly lower across the board.
Everybody's had access to the, once they get to that round, everybody essentially has access to the same training methods.
I'm not saying they're the same or the same quality, but they receive the same training.
Exactly.
So it goes back to genetics that those people,
or natural ability.
Right, were affected by that training. So two guys training at the same thing, one guy's going to be faster because of genetics or
natural ability, or some other variable that I'm completely ignoring right now that I've forgotten about.
Hair.
But hair. Or hey, Spitz had to swim with that friggin' mustache.
I know, the stash.
That's crazy.
Holy crap!
They would never do
That's
that.
drag!
They would
It's like
never
someone
do
with a
that.
diaper on your face. I just said that. Veronica.
Well, because they were all relatively close to each other, we can assume that it was pretty standard.
I think that's a good argument. I think that's a good
So
argument.
if we had someone that had a significantly different number within that set, then we would have to question it a bit.
Like Spitz did. I mean, Spitz blew the competition out of the water that race. Where Phelps did too, but not as what I would call impressively.
Okay.
Is that fair? I love what you guys are saying, and that's why I'm trying to impress upon you. This is just my way of looking at the data. I mean, Di, you asked the best question. Who's the most impressive swimmer? The first question you asked, what do you mean by that? What do you mean by that? This is what I mean by it. I mean, this is the only way I can think. I mean, that's a great question. Define the variable, yeah? It's amazing when students, 9 times out of 10, I'd say, maybe 19 times out of 20, when students bring me papers to look at for their other classes, they're like, I don't understand this. And I go through and read, I'm like, I don't understand it either. Because the variable was never defined. Well, pain was increased. Define pain, right? Define pain. Is it the kind of pain you can breathe through? Is it on a pain scale of 1 to 10? Okay, how do you rate that measurement instrument? This is time on a clock. I can trust this, right? This is pretty much inarguable. I'm guessing. I mean, if it's an Olympic level, you'd think it would hopefully be. So I try to pick stuff that I can actually measure. Speaking of which, here's the 100 flying, the 200 free. Now, I have the data too. I just didn't put the data up on but here's the average. Oh, no, I didn't give you the average.
Actually, that's a pretty good question, Sean, because I guarantee you the timing in 2008
was more precise
exactly
than it was because of stopwatches in 72 versus touchpads in 2008. Yeah, that could very well be. But it would be easier, probably from a human perspective, to focus on Spitz coming in first because there's less peripheral distraction, if you will. And I lied to you. I don't have the data here right now. I apologize. But I have the Z-scores. I can get the data for you, and you can do it. I mean, it's easily Googleable.
No, that's the most important part anyway.
This is, isn't it? The conclusion. So once you look at the 100 fly, Spitz had a Z-score of negative 1.7, Phelps 1.4. So who am I going to vote is more impressive in the 100 fly?
Spitz.
Once again, Spitz. So Spitz, in my book, is a better flyer than Phelps is, but check out the 200 free. Check out the 200 free. That's when I switch over to Phelps, and I'm like, he was more impressive than the 200 free. And it'd be fun, I don't have the data in front of me right now, to find the raw data to see if he blew his comp. Did anybody remember seeing that in 08, the final gold medal round? Did he destroy everybody in that event?
There was one that he didn't. I forget, I don't know if it was the backstroke or whatever. Where
He won gold, but it was close.
Like, oh my God, it was like
so close.
So close.
Like his long finger was what got him the gold
Yes.
medal in that one, yeah. Gotcha, that big size 18 foot of his. Good. But so this is a way for me to measure significance. I mean, it's a way, not the only way, but it's just a tool. And the beauty of it is, here's the real takeaway. The real beauty of this whole method is what you've done with, this is the formula, if you want a formula, and here it is, it's gorgeous. We'll use it all over the place today. This is what you guys already did conversationally. You took a data point, found its difference in distance from the mean, and then weighted it with the standard deviation. That's how you got your 2/3 and 1/3 on the IQ question. We'll go back and do it again in case you didn't see that. What that does is it converts down to a Z-score, and then you can slap that bad boy up onto the standard normal bell curve that we learned about on Tuesday. That's the conversion. You guys are like, aha, there it is. Yeah. That's it. You guys were doing a conversation yesterday too. Excellent. Yeah. But that's the conversion. That's the move. That allows you to get from any curve you're on back to that one. And you know how much I hate showing you guys formulas. I try to hide them from you. I mean, I do. I do my absolute best to keep them away from you. This one is too crucial not to talk about. It's huge. It's absolutely huge. If you're taking 244, we use this every day in 244. So don't memorize it right now, obviously. You'll have ample time to memorize this 244 with us. But the fact of the matter is that this is a huge tool. This even works if you don't have bell-shaped data. It even works if you don't have bell-shaped data. It normalizes down so that you have an average of 0 and a standard deviation of 1. I didn't believe that the first time my prof told me that. We learned this in class. Yay, learned it in class. And they said, yes, average of 0, standard deviation of 1. I'm like, Dr. Mason, I don't get that. Why? How would that work? It's like, well, I've been teaching this for 35 years, and that's just the way it is. I'm like, yeah, that's like the worst answer I've ever heard. That's the why can't I go out because I said so answer. Yeah. So, if anybody's interested as to why, I proved it for myself. I sat down with the mathematics and actually went through the distribution. It's on your website, like every other proof of everything else that I mentioned. So you got that for you if you want to see it. And it's gorgeous. It really is. It's one of the more simple proofs to show that these, if you average all of these in a distribution, it's going to be 0. And some of it, you already know why. If you remember, and you probably don't, it's okay. Do you remember doing something like this before with Bert and Ernie?
Yeah.
Do you remember when we manually calculated, I think it was Bert's standard deviation, we took the difference of each of his test scores from his average, and then we summed those differences, and they summed up to 0, and they always will regardless of the data. So that's why it has an average of 0 right there. It has to have an average of 0 because the sum of the deviations is always going to be 0, regardless of your data set. That part's actually easy to prove. It's the standard deviation that gets fun. Some of the deviations is always zero. That's why we had to square them. That crazy square root of the squared formula, the reason we had to square them was because the deviations themselves always add to zero. That doesn't help us. That doesn't help us talk about differences if everything looks the same. Now, we haven't seen that in five weeks, at least.
So if you had the same data or the same swimmers, if you
Yes.
you can compare through time.
You can compare through time, which I have not done. But you can easily go Olympics to Olympics to Olympics to Olympics to Olympics and see if anybody stood out more in their field from somebody else via standard deviation measures. And thank you, Pat, for that. This number that results is a number of standard deviations on this beautiful little curve over here. Once you get, it's going to place you on this axis. The further you are from zero, the more extreme or the more outlierish you are. So Phelps and Spitz are obviously outlierish because they're the fastest times. So is last place, I would imagine. I'm guessing last place is pretty much outlierish compared to those 8 guys. I mean, they're also outlierish compared to any of us that swim at Juniper in the morning because they kick all our asses. But the idea is, once you've run that calculation, you're on this axis, and yay, and we're ready to go. So after the break, let's take 5 now. After the break, let's go back to the IQ, and then tie some other context into it too. Now we got this beautiful tool. I want to use it. I want to make sure you guys are comfortable using it. I want to make sure you know how to do forwards and backwards problems using it because they're both important in research methods. Let's take 5 first. Yes? Yes, I think we should. Yes, I agree. Yes, I concur.